Hello, everybody. It's Mrs. Pound, and I am back with a new chapter. And you'll probably notice that I have a different location too. I'm at school today instead of at home, so we'll give it a try here. Well, we have finished up talking about rocks and minerals, and now we're going to move on to chapter 2.1, which is about weathering and erosion. And the first section, section 211, is about mechanical weathering. So, our objectives today are to identify and explain several processes of mechanical weathering, to assess the effects that climate, rock type, and exposed surface area and topography have on mechanical weathering, and apply concepts of mechanical weathering to technological designs. So, one important thing we have to get taken care of right away is the difference between weathering and erosion, because we tend to, when we talk about erosion, really be describing weathering. So be careful with these definitions. Weathering is the breaking down of rocks into smaller pieces by mechanical or chemical processes. And you can see here this rock has a lot of cracks in it, okay, and that rock is being broken down, so it is being weathered. Erosion is the removal and transport of material by wind, water, or ice. And here in the background, I have water that looks pretty muddy. It has a lot of sediment in it. And so erosion is taking place. The water is moving the sediment, the particles that have been broken off, have been weathered from rock, or perhaps it's moving soil or other things. But this is erosion, the removal and transport. So there are two types of weathering. There's mechanical and there is chemical. We're going to focus on the mechanical weathering today. This is the breaking down of rocks by physical processes. And I have some headstones in the background because oftentimes we can see weathering on these headstones. If you look at the lettering on these are very old headstones, and they can be hard to read because the stone that they are made of has been weathered. Now, when it's mechanical weathering, this is mostly caused by temperature extremes and the activities of living things, which is biological weathering. So, temperature and the biological weathering is due to things like tree roots, plant roots breaking apart the stone. The rate of weathering, the rate of weathering is determined by the climate, the type of rock, the amount of exposed surface area, and topography. So let's take a look at each of those things. Let's take a look at first climate and how that affects it. So very common where we live. We live in Western New York, and ice wedging is a big deal here for mechanical weathering. This is the mechanical weathering process in which water in the cracks of rocks freezes and expands, widening the cracks. You might not notice this so much in rock, but you do notice it on our roads. When winter is over, our roads are a mess. There are tons of cracks everywhere, and that is due to ice wedging. Water seeps into those cracks, it freezes, it expands and pushes the cracks apart in the road. Then it thaws and it retracts, and then more water gets in deeper into those cracks. It freezes, expands, and so on and so forth. And so that is why our roads need so much repairing in the spring. So we are pretty familiar with this concept. It is due to changes in temperature in particular, that constant thawing and freezing that is going on in our area. Now, this can also happen in the desert. Now you're saying, but it's dry in the desert. Well, in the desert, moisture doesn't have so much to do with it. In the desert, it's called exfoliation, and this is mechanical weathering that occurs in the desert due to rock expanding in the heat and contracting in the cold. So there is still that expanding and contracting, but now it's not water. It's not something else doing it. It's the rock itself. And so you do also get this type of weathering in the desert It just may take longer than it does in our northern climates that are wetter. The type of rock also determines the rate of weathering. The most easily weathered type of rock is sedimentary. It just, because of the layers, it has the cracks that, say, water can get into. It also is not as hard, tends not to be as hard as igneous or metamorphic rock. It does not have that crystal structure. And so it already has like particles that are cemented together. And so those are easy places for water to get in and work. Now, also a factor is surface area. The greater the exposed surface area, the greater the potential for weathering. This is a factor for many things. Surface area, think of when we're dissolving substances, okay? So here I have a picture of the Colorado River going down the Grand Canyon, a lot of exposed rock surface there, so a great potential for weathering. Another factor is looking at all of the cracks between the rocks. The more cracks and everything you have, that all increases the surface area. So the more cracks you have, the more surface area you have. The smaller particles you have, the more surface area you have. Just like with dissolving something like sugar, you're going to dissolve granulated sugar a lot faster than you are sugar cubes, because the granulated sugar, all those little grains of sugar, have give it a larger surface area. And finally, topography. Topography is the surface features of a place or region. So what does the land look like? Think of a topographic map. A topographic map, its whole purpose is to give us an idea of the land features, the elevations, what is there. In higher elevations, this encourages weathering due to greater temperature extremes. You're going to get that ice wedging that we just talked about. So I have a mountain in the background that has snow at the top. So the higher the elevation, the more weathering you're going to get due to those things. Also, steep slopes, like in the Grand Canyon, are affected more by gravity and water from heavy rains. You've probably all driven along the road somewhere where there is a rock face, a steep cliff there, and there's a lot of sediment at the bottom that has fallen down. And you're going to notice that at the steep slopes because of gravity and the rain acting on it. Now, that means we have to consider these things. We have to consider weathering when we're building. So some building considerations are foundation reinforcement. If you're building on a hill or a steep slope or something like that, you might have to reinforce the foundation. In the background here, I have a retaining wall. This is pretty steep. They've built a wall, and you can see they're reinforcing it with iron and all kinds of things to hold that in place. Otherwise, it will weather and it will erode and it will go away. Some other considerations might be sealing building stones so that there's a sealant over them and the water will not get into the cracks and cause things like ice wedging. Also, improving drainage. If you don't have the sitting water and everything, it's not going to carry away the soils and all of that kind of stuff. So improved drainage. These are some considerations when you have to build. So our objectives were to identify and explain several processes of mechanical weathering, to assess the effects that climate, rock type, exposed surface area, and topography have on mechanical weathering, and to apply concepts of mechanical weathering to technological designs. Engineers and architects have to consider weathering and erosion when they are designing buildings and roads and whatever they are working on. It's an important factor. So remember your 5 questions, and I will be back with more in this chapter on weathering and erosion.